Hello students, welcome to Neet Gateway. So we have previously saw 8 videos based on chapter 7 class 9 motion chapter. So today we are going to discuss the next chapter 8. The chapter is force and the laws of motion. Force and the laws of motion. So in this chapter we are going to discuss the topic on force and Newton's first law. So we are going to discuss what is a force. So Newton first law defines a force. It also defines another one concept called inertia. So these are all the topics we are going to cover in this video. So watch thoroughly and watch fully and keep on watching this. So see, before entering into the definition of the force, before we are going to see the historical statement given by the philosophers and the scientists about the forces. So not only the philosophers, we are going to take the two main statements by the big scientists. One is Galileo Galilei and another one is Isaac Newton. So a body moving on a level surface will continue in the same direction at a constant speed unless it is disturbed. So if the body is not disturbed, means the body continues to move in the same state, continues to move in the same surface, okay, in the same direction at a constant speed. So this indirectly tells you about the inertia concept. I'll tell you later what is inertia. So just recognize the statement now. So next, Isaac Newton. So who defines the law, who defines the force, and he gave three laws based on motion. Okay, so three beautiful laws of motion. Newton first law, second law, and his third law. Okay. So the change of motion is proportional to the motive force impressed and is made in the direction of the straight line in which that the force is impressed. So the change in motion is applied in which direction is depends upon the force applied on that direction. It depends upon the force applied on the direction. So it is Newton's second law. So today we are going to see, in this video we are going to see only about Newton's first law and some what is force and what is inertia here. So listen carefully. So what is a force? So force is a fundamental concept in physics. So by a common people you can say, so if you go to a common people, if you ask a question like what is a force means, they will answer you it's a pull or a push. You can pull a body or push a body with help of force. That's a force. So it is an action. So it's an action, right? So that describes a push or a pull. It describes the push or a pull. It describes the push or a pull acting on an object. See in this diagram, a person is pushing a block of mass in a movable vehicle. Okay. So he is applying the force in this direction. The object is also moving in this direction. Okay. So wherever the object is moving means there will be the force. Okay. Very important. So he giving some applying some force. That is applied force. Okay. The unit of force is, the SI unit is Newton. So who described the force very neatly? Sir Isaac Newton. So the unit of force is named after him, Newton. Got it? So what is a CGS unit? So SI unit is Newton and CGS unit is dyne. Okay, another form of unit. CGS unit nothing but centimeter, gram, second. Okay, another form of units. So okay, SI unit is Newton and CGS unit is a dyne. So force is a vector quantity or a scalar quantity. So we know that force it depends upon the motion, direction of the motion. Where the direction of the motion moves, on that same direction only force will apply. So force depends upon the direction. So force is a vector quantity. Force is a vector quantity. So you should represent the force with the vector. So keep remain this mind. Okay. Yes. Effects of force. So we have studied what is a force. It's the action on an object. What type of action? You can pull an object or push an object. So it is an action on an object, right? See, so by giving some action on the object, what are the effects faced by the object? The first effect is change in motion. So in the previous slide we saw a man is pushing a box. Okay, So when the box is in rest position means, for example, when a box is in rest position, it doesn't move. If I apply some force to it means what will happen? It starts to move, right? It starts to accelerate. It starts to accelerate. So the force, what is the effect on the bots? It changes the state from rest to motion. So the same way, when the body is in motion means, when the body is in motion, for example, this body M is moving in this direction towards rightwards. So I am applying some force. What will happen? Its speed will increases. Okay, because I am applying the force in the direction of the motion itself. Okay, in another case, the direction of the motion is in this direction towards the rightwards, but what I am doing here, I am going to apply some force opposite to the direction of the motion. What will happen? Its speed will decreases. So you are giving some opposite force. So that's why here a force can start or stop the motion. A force can start or start the motion. So the change in motion can be based on speed or in direction. It can increase or decrease the speed. So I have given the example, right? It can increase or decrease the speed. It also able to have ability to change the direction of the motion. So if I give you, for example, the block is moving in this direction. If I apply force in this direction, then what will happen? It will move, starts to move this way. Okay, so it is also able to change the direction of the motion. It can also decreases or change the direction of the object movement. Can you able to understand? Yes. So example, I have given some example based on blocks. The real life examples are kicking a stationary football. So the object is initially at rest. When I kicked it, it moves, it starts to move. So it changes its states from rest to motion. So applying brakes slowly on a moving car. So see here the car, the man is applying the brakes. So what happens? The car starts to stops. Okay, so its speed decreases. Okay, here the speed, ball of the speed is increases. Okay, let's change in shape or size. What is the first effect? It may change in the speed of the motion. Speed will be increase or decrease, or it will change the state of the motion from rest to motion or motion to rest, or it will change the direction of the motion. Next effect is change in shape or size of an object. Change in shape or size of an object. For example, if you are holding a rubber ball, not a rubber ball, a sponge ball. Okay, so if you compress the sponge ball by applying some force on your hands, on the fingers, what will happen to the sponge ball here? The sponge ball will compresses. After releasing the finger, after releasing the force, what will happen? It will regain its to its original position. So what is the effect of force on the ball? The effect of force is changes the shape of the ball. So see here, it is in red color, full shape. After applying some forces, after compression, what will happen? It changes its shape and size. Got it? So a force can deform an object. Deform means, so changing the shape is called as deforming. Okay, so forces can deform an object, stretching or compressing or bending it. How we can? You can stretch an object or bending an object, and another one is compressing the object. So example, squeezing a rubber ball changes its shape temporarily. So you're applying deforming. So after releasing, it becomes reform to the original position. After releasing force, what happens? Reform to original position, original shape. Here deforming force applied, it deforms. After releasing the finger or after releasing the force, reform to the original shape. So keep this in mind. So before entering into the first law of the motion, you should know what is balanced force and unbalanced force. See here, it's easy only, not a big deal here. See, so balanced force are equal in size and opposite in direction. So considered in an object, there are two forces are acting. Both forces are equal to each other. For example, here 5 Newton means one force F1 is equal to 5 Newton means F2 also 5 Newton. If the same force acting opposite to each other, see here a trolley of load is pulled by some group of people here, and the same trolley was also pulled by some group of people. Okay, both are pulling it in opposite direction, right? So force is applying opposite direction. Whether these two are equal, yes, they mention you the blue team represents the left force gives you 350 newton and the right force gives you 350 newton. Whether the trolley moves, no, because the net force on the trolley is what? The total F net means something but the net force, the total force. So F naught is equal to what? Consider this is a blue team and here it is the red team. So red FR minus FB. So which is equal to, both are equal, right? 350 minus 350. So which is equal to 0. So when F net is equal to 0, whether the object moves, it does not move. It does not changes its position. It remains in the rest itself. I'll tell you later, we can study this in this Newton's second law. If the net force acting on the body is 0 means it is under equilibrium. We can say it as a equilibrium. So if you came across the word equilibrium means what? For example, in a problem they will say you an object is to be in equilibrium, which means the net force acting on the object is 0. The F net on the object is 0. That is the indirect message of the word equilibrium. Okay. So if they are applied by two equal and opposite force on a single object means then that forces are called as balanced forces. Okay. Same way, unbalanced forces are nothing but opposite to the balanced forces. See here, if I am applying some 50 Newton in the right side and 30 Newton in the left side, whether they balanced each other? Not at all, right? Not at all. So here only 30 Newton is pulled and the red team was pulled by 50 Newton. Okay. So unbalanced forces are not equal in size or in direction. They do not cancel each other and cause a change in motion. And what will happen? The higher forces are acting in this direction. So for the object, the trolley moves in this direction only. Same way, a man is trying to push a box. So he is applying force how much? 199 Newton. So the friction is produced opposite to the motion. Okay, we will study what is friction, don't worry. So friction is studying, the friction is produced opposite to the motion. Friction is how much? 94 Newton. So applied force is how much? 199 Newton. Okay, so what is the F net? 199 minus 94, which is equal to 105 Newton. Got it? Yes? Okay. So this is the unbalanced force. Summary table. So when the net force is net force, motion effect, object at rest, object in motion. But in balanced force, what is the F net? I have told you 0, right? In unbalanced force, F net not equal to 0. It will have some value. Okay. So first is over. What is motion effect? It does not change. When the F net is 0 means it is in equilibrium position. So equilibrium means what? The total force on the body is 0, which means it is at a rest. No change in motion. Okay. Causes a change in motion. Yes, it definitely causes changes. Object at rest. If the object stays at rest means it always stays at rest. If the object stays in motion means it keeps moving at a constant speed, not a variable speed. So for example, listen very carefully. An object is moving with a velocity v. Okay. If there is a balanced force, here 5 Newton and here also 5 Newton means whether the body will accelerate? Not at all. Here the acceleration is 0. Why? Because the F net is 0 here. So body does not accelerate, it continues to move with a constant speed. Got it? So for unbalanced force, cause a change, starts moving. So unbalanced force, if you give a force on a rest body means what will happen? It starts to moving. If you give an unbalanced force in a motion means it speed ups or slows down or changes the direction. Can you able to understand very clearly, right? Yes. Newton's first law of motion. An object remains in a state of rest or of uniform motion in a straight line. So for every law, you should always give importance on the wordings. So the wordings are very important. You cannot be able to alter the wordings. Each wording gives you the specific meaning. Okay, an object remains in state. What state and all? In rest or in a uniform motion. In the first class itself, I have told you in the previous chapter. What is uniform motion? Uniform motion means the body is moving in a constant velocity. So, uniform motion in a straight line, unless compelled to change the state by an applied force. So, if your body is in rest or moving in a uniform motion in a straight line means, unless you are applying any external forces, the body, the state of the body doesn't change. The state of the body doesn't change. So, Newton's first law introduced two concepts here. Introduce the two concepts. One is, what is force? It defines force. And another one is inertia. So one is, Newton's first law defines two concepts. One is, it defines the force. What is force? And it also introduced the concept of inertia. Okay. So force is nothing but needed to change the motion. Start, stop or turn. It will rest to motion or motion to rest or change the direction. So effects of force we studied, right? So what is inertia? Very important. It introduced a new concept called inertia. The natural tendency of an object to resist the change to its motion. So okay. So listen very carefully. So each and every object have some resistance to move. Yes. So it depends upon what? The mass of the object. If the heavier the mass, it has heavier resistance to move. If the lower the mass, it have lower resistance to move. That resistance is called as inertia. The natural tendency, it's by itself it have some own resistance of an object resist to change its motion. Okay. So okay, listen, inertia. So inertia and its types. Okay. Inertia is the tendency of an object. So it's a natural tendency. It is occurring by own itself to resist any change in its state of motion or rest. To resist any change in state of motion or in rest. Okay. So every object has some resist to move. That resistance depends upon whom? The mass of that respective object. Okay. So that resistance is called as what? Inertia. So the greater the mass of the object, the greater its inertia. So mass is the measure of inertia. Very important point. Mass is the measure of, how you can measure the inertia? By using mass. Mass is the measure of inertia. Okay. Inertia is not a force. It is a property of a matter. See here, it is a small cube, right? So it is a small inertia. It is a large cube, so it is a large inertia. So it depends purely on the mass of the body. So it is not a force. Inertia is not a force. It just tells you the property. By which property? The mass. Okay. So listen carefully. So we have saw the inertia now. Next we are going to see the types of inertia. Inertia of rest, motion and direction. Yes. The three types. Inertia is on three types. One is inertia of rest. The tendency of an object to remain at rest unless acted upon by an external force. The tendency of an object to remain at rest. So the object is okay. When object is at rest means it remains at rest unless an external force acts on it. Okay, it will give resistance to the motion. When object is at rest means it will give resistance to change its state from rest to motion. So, okay, how we can see some example. So, a coin placed on a card over a glass stays still when the card is flicked away. The coin drops straight down. See here, this finger, I am tapping the board on by my finger. Okay, I'm tapping the board by my finger. Consider I'm tapping the board by my finger. So I'm applying the force on whom? The board only. The board carries some coin. The board was held on the beaker of glass. So after applying some force on the board, tapping the board, what will happen? The board moves on. The coin also does not move with the board because the coin is having contact with the board only. I am not applying any force on the coin. I am applying the force on only the board. So before applying the force, what is the coin's state? It is in rest position, right? It's in rest position. Okay. So what will happen? The coin resists itself to change its body from rest to motion. Yes or no? Because the board does not move. The board only moves. Along with the board, the coin does not move. Because what is happening? Here? The coin resists itself. The coin resists itself by not changing from rest to motion. I am going to stay on rest itself. Okay. Okay. So who giving that resistance? The mass of the coin. The mass of the coin. So what will happen after the board blown away? What will happen? The coin fell down into the glass of water. Okay. So this is the best example for inertia of rest. Okay. Inertia of motion. Okay. First type is inertia of rest. Second type is inertia of motion. And third one is inertia of direction. So the tendency of a moving object to keep moving with the same speed and direction unless a force acting on it. Listen very carefully. Okay, in before case, inertia of motion rest, we saw the body tends to be in the rest unless an external force acts on it. Here the body continues to be in the state of motion. What type of motion? In a uniform motion in a straight line. So same speed in the same direction. So unless an external force acting on it, it does not change its speed or does not change its direction. So okay, this is the inertia of motion. Listen carefully. A moving bus suddenly stops. Passengers lurch forward because their bodies tends to keep moving. Okay, listen carefully. So you are traveling in a bus. So you are not having any seat to sit there. So you are standing in the bus. Okay, the bus is in motion. You are also in what motion only? Because you are having contact with the bus, right? So the bus's motion means you are also in the motion. When the bus applies the brake, what will happen? What will happen? The body, before applying the brake, the body is in motion. So what will the body do? The body continues to be in the state of motion only. Because you are having some mass. Due to some mass, it produces some inertia. So when applying the brakes, the body continues to be in the state of motion only. So it doesn't come to the rest because the driver applies force on the bus only, not on you. Okay. So for that reason only, after applying the brake, we are lurching forward. For that reason only, we are lurching forward while applying the brakes because we are having some inertia. So before applying the brakes, you are in the state of motion. So you can't be able to change its the inertia of the body has a tendency to resist the motion into rest. So it suddenly it doesn't come to rest. So you are having some mass. Due to some mass, you are producing some inertia. So you are moving forward. So you continue to be in the state of motion only. Okay, nice. Next, inertia of direction. Okay, the tendency, inertia of direction. The tendency of an object to keep moving in the same direction unless acted upon by external force. So when the external force acted upon it, it keeps moving in the same direction itself. Okay, best example is when a car takes a sharp turn. When a car taking a sharp turn, passenger feels sideways push. Their bodies resist the change in direction. Okay, so you are applying the force on the car only to change the direction of the car. Okay, but you are not applying any force on your body to change your body to direction. Before applying the force on the car, the body is in straight line only because you are traveling straightly. Okay, so after applying the direction, what will happen? So your body doesn't change immediately, it will push outwards. Okay, so this is the inertia of direction. Okay, yes. Let us see some problems based on the following discussion. Which one of the following has more inertia? More inertia. So mass is the measure of inertia, right? Mass is the measure of inertia. I have told you this. Mass is the measure of inertia. Okay, a rubber ball and a stone of same size. So who is having more mass here? Definitely the stone, because stone is more denser than the rubber ball. So stone is the answer. Rubber ball is less dense. A bicycle and a train. Who is having more mass here? The train having this more mass. So a 5 rupees coin and 1 rupee coin. Definitely the 5 rupee coin will be bigger than the 1 rupee coin. So it metallic weight is higher than the mass is way higher than the 1 rupee coin. So 5 rupee coin is having more inertia. Okay. So in the following example, trying to identify the number of times where the velocity of the ball changes. The velocity of the ball. Velocity of the ball means does not depends only on the speed of the ball. It also depends upon the direction of the ball, because velocity is a vector quantity. Keep this in mind. So velocity changes means it has the chances of change in speed and also have the chance of change in direction. Okay, a football player kicks a football to the another player of his team. So a football player takes this. Okay, so first one is kicks. So speed changes. So, okay, who kicks the football to? So who's player of his team? So a football player kicks a football to another player of his team. The another player kicks the football towards the goal. So the another player kicks the football to the goal. The second one is it reaches in the goal. Okay. Next, the goalkeeper of the opposite team collects the football. So the goalkeeper, whether he will stay simply, he or she will try to block the ball, right? So the ball is blocked. Okay. The question is velocity of the ball. The velocity comes to 0, right? So the goalkeeper changes the velocity. Goalkeeper, third time. Next, the goalkeeper of the opposite team collects the ball. Okay, that's the goalkeeper stops and kicks towards the player of his own team. So after stopping the ball, the goalkeeper kicks. So how many times the velocity changes? 4 times. Is there any other? Also identify the agents applying the force in each cases. In first case, football player, and second case, another opposite team football player. Opposite team football player. And third one is goalkeeper is blocking the ball. So velocity comes to 0. So it's changing. And fourth one is the goalkeeper again kicks the ball to his own teammate. So 4 times. Okay. Explain why some of the leaves may get detached from tree if we vigorously shaking its branch. So see, consider this is the branch of a tree. Okay, in this branch there are many leaves. Consider as a branch. Okay, so in this branch a person is shaking. Okay, the person is shaking the branch. What will happen if you shake the branch of a tree? Means what will happen? The leaves may fall down. So before shaking, the leaves are in which position? At rest position. So inertia will produce on the inertia. If you start to shake the branch means what will happen? It changes into motion, but the leaves will produce some inertia because due to leaves having some masses. So it has their own tendency, natural tendency to change its state. So the resistance will produce by the leaves. So due to the resistance, the leaves are cut down. So the correct reason is it produces the inertia of rest. Can you able to understand? Yes, inertia of rest. So why do you fall in the forward direction when the moving bus brakes to stop, and fall backwards when it accelerates from rest? Okay, so we have already see this case in the example itself. One is inertia of rest, another one is inertia of motion. So you will definitely experience these two cases when you are traveling in a bus. So consider, for example, in inertia of rest, what is happening means you are in a bus stand. The bus is at the rest position in the bus stand. So you all sit in the seats. So the bus driver came to the bus and he starts the bus by providing the keys. What will happen? From the rest position, the bus starts to accelerates. So you are in contact with the bus, right? Yes, you are in contact with the bus. So the bus driver only giving the acceleration to the bus only, not for you. Okay. So what will your body do? Your body will resist the change. Before applying the keys, your body is in rest position. Due to your body having some mass, it produces inertia and always likes to stay in the rest position itself. So due to your by the reason of having contact with the buses, the bus starts to accelerate and you also start to accelerate. Before going to acceleration, you will give some resistance. So that resistance will be, the bus is moving accelerated, move forward means your resistance will be backward. So this is the inertia of rest. Okay. Inertia of motion means, what is inertia of motion? We have already, you are standing in the moving bus. Okay, your bus is in motion, you are also in motion. Okay, now when the bus suddenly applies the brakes, what will happen? You will jerk forward. Why this is happening? As I already told you, the bus is in motion and you are also in motion. Your body having some mass, so the buses are only having, the brakes are applied only to the bus, not for you. Okay, so what will happen to your body? Your body doesn't like to change the state. It continues to be in the state of motion only. Okay, it continues to be in the state of motion only. Yes. So due to bus, you are having contact with the bus, right? Your body, the body's lower part is having contact with the bus. So what will happen? The bus comes to rest. Your body wants to also come to rest. So before coming into the rest, your body is giving some opposite resistance. So you are coming forward. Can you able to understand? Yeah. Yes. So in the next part, we can see the momentum and change in momentum and Newton's second law of motion. So okay. So kindly watch this video without any break. Thank you.